Welcome to the Math 1 lesson summary video for the task Growing Dots. So this is a develop understanding task, and that's important because in a develop understanding task, you're not meant to be an expert by the end of the task at all the skills associated with that task. You're just meant to be introduced to them and to begin to start to think about what the skills are going to be that you'll need to master. So it's important to keep that in mind. Not meant to be an expert by the end of this video, but you are meant to have an idea of what you're going to be learning and practicing. So this task in particular is developing multiple representations of an arithmetic sequence. So let's just dive in and then we'll talk more about what that means. So we can see, if you read the scenario in your module, you're given a series of dots. We're given at the beginning, at 1 minute, at 2 minutes. We are asked to figure out how many dots there will be at 3 minutes. Then we're asked to figure out how many dots there will be at 100 minutes. And then also at t minutes. And so 3 minutes is pretty easy. So some students may just dive straight in and say, okay, I can take the 2 minutes picture and I see what's going on here. Every time it's growing by 1 dot on each of the wings of the x, maybe you might think. And so we can begin to fill in a table. So at the beginning, we had 1 dot. At 1 minute, we had 5 dots. At 2 minutes, we had, that was 9. And then at 3 minutes, we had 13. And so we can now start to think about and anticipate, well, what's it going to be at 4 minutes? And in order to do that, we need to start to compare each consecutive part of the sequence. So a sequence is just a list of numbers, in this case, the numbers of dots. And so what we're doing is we're thinking about this recursively. And so recursively means, how do I get from one image to the next? How many dots are we adding every time? And so we can see that that's 4 dots that we're adding every time. So this is an arithmetic sequence because the amount being added every time is constant. So this idea right here of an arithmetic sequence, it has to have what's called a constant difference, meaning the amount being added is the same every time. In this case, it's adding 4 every time. So if we continue that adding 4 pattern, we can get 17 and 21. But to answer this next question and so again, at 3 minutes, that was 13 dots was the answer to the question. To answer this question of 100 minutes, that is a little bit harder because I don't really feel like adding 95 more times. You might, and you could, but I wonder if there's a more efficient strategy. And so to get there, let's break down this series of images in the way that 3 different students might represent it. So one of the most intuitive ways is the way we were kind of just talking about. And you can see that represented here with student 1. And so you can see each time student 1 is seeing the plus 4 dots being added on. And those are represented there in pink. So there's the 4 dots being added in each image. And so that's a recursive function, or a recursive way of thinking. And so if we wanted to write a representation for that way of thinking, this is what it might look like. And this is just kind of a preview of what you're going to be doing more and more. So we would say x sub n, meaning some number in the list, equals x sub n minus 1, meaning the previous number in the list. So if I'm looking at the 10th number, then 10 minus 1, I would do something to the 9th number. And so how do we get to the next number in the list from the previous number each time? We added 4. And then we also need to indicate where we started. So at the beginning, at x sub 0, there was 1 dot. And so that's a recursive representation for what's going on. That's an algebraic way of representing this idea that we're adding 4 every time. Another student might look at it more explicitly. They might say, I see, and I'm focusing now just on the 3 minutes picture. They say, I see 1 dot, and I see that there's 4 arms creating kind of a pinwheel or an X. And so every time the number of dots in each arm is equal to the number of minutes that we are in the sequence. And so you can see that there are 4 arms. So we might start to be able to represent how many dots there would be at 100 minutes using this strategy a little more quickly, because we have 1 dot and we have 4 arms, and in each arm there are a certain number of dots. So in this case, at 3 minutes, there are 3 dots in each arm. So we get 1 plus 4 times 3, which is 13 dots at 3 minutes. Just like we did earlier by just extending the pictures using recursive thinking. But if I use this idea now to figure out how many dots there will be at 100 minutes, well, that's 1 plus 4 times 100. Because there would be 100 dots in each of the 4 arms, plus the 1 dot in the center. And so that way we get 401 dots at 100 minutes. So let's go back up here and fill that in. 401 dots. And that's nice. So to represent at t minutes, well, we just keep the same idea, but it would be 1 plus 4t. Because at any number of minutes, 3, 100, or t, there are t dots in each of the 4 arms in this visual way of thinking about it. So thinking about this multiple representations, we have come up with an explicit formula, and so I'm going to call this one d equals, because the number of dots equals 1 plus 4 times t, where t represents the time, the amount of minutes. This is called an explicit representation. So we have a recursive representation and explicit representation. Those are algebraic. We have the visual representation that we started with. So we're fulfilling our purpose of developing multiple representations of an arithmetic sequence. And so one third way I want to show you that students might think about this that connects to that explicit representation is this picture here. So again, I'm focusing on the t equals 3 time. And so I have the 1 dot in the center per usual. So let me cover over that in blue. And then some students might say, oh, well, I see a square of dots being added in the first picture. And then in the second picture at 2 minutes, I see another square of dots being added. And then in the third picture at 3 minutes, I see another square of dots being added. And so that connects to this representation as well, because we have the 1 dot in the center plus 4 dots every time representing the 4 corners of a square. And so how many squares do we have in each scenario? Well, at t equals 3, I had 3 squares. So 3 times 4 is 12 dots plus the 1 is 13. And then at 100 minutes, I'd have 100 squares around that center dot. And at t minutes, I would have t squares at that center dot with 4 dots on the corner of each square. So that's another way we could arrive at this explicit representation. So again, just a develop understanding task, just trying to introduce you that you may represent arithmetic sequences, which are sequences that are growing by a constant difference, using recursive formulas or explicit formulas or visually. So thank you for watching. If you need more specific help with the Ready, Set, Go problems from your homework, then check out the Ready, Set, Go video support site in Canvas.